Okay, now in this video we are going to cover the volume part of integration. Volume when an area bounded by a curve and the x-axis is rotated through 360 about the axis, a solid or revolution is formed. So that means even if you get an area which is bounded by the axis, by the curve and the axis, and that area is rotated 360 degrees, that forms a volume. So that area forms a volume. Just like this over here, if I had this as a simple area in two dimension, and if I would rotate this 360 degrees about the axis, about this axis, it will form a cylinder shape. It's just going to form a three-dimensional shape. So that's going to give me the volume. Anything that has a three-dimensional shape is going to give me a volume. Anything that has a two-dimensional shape is going to give me the area. So that's why in volume you will always see this written through 360 about the axis of the solid revolution is formed. Now over here says rotating about the x-axis for a region R enclosed by a curve, and the curve is in the form of y equals to the function is in terms of x. The x-axis and the lines x is equal to a and x is equal to b. The volume generated by rotating r about the x-axis is given by volume is equal to pi integrating y squared with the limits applied. So all you have to do is the equation of the curve will be given to you, and that equation of the curve has to be squared first, then integrated, apply the limits like you do in the area. Whatever your final answer is, multiply your final answer with the pi, that will be your volume. Using the same concept of volume over here, I've taken out one question for volume, which is this. Now let's read this. This is question taken from June 2017, variant 1-2, question number 6. Over here we see a straight line and we see a curve. The curve has the equation y equals to 4 over x. The straight line has the equation x plus y is equal to 5. And the curve and the straight line both intersect at the point 1, 4, at A 1, 4, B 4, 1. So the equation of the straight line given as x plus y equals to 5, that's right over here, that's the straight line. The equation of the curve y equals to 4 over x. Find, showing all necessary working, the volume obtained when the shaded region is rotated through 360 about the x-axis. So the concept of doing the area question and the volume question is exactly the same, only the formula is different. The formula over here would be y squared, limits applied, multiplied by pi, instead of just having this as y and applying the limits. So in volume, you're going to do exactly the same thing, just square this and apply the limits, multiply this by pi. That's what we're going to do over here. So what is our curve over here, the line over here? So we always take the line which is above. So this line is above the curve, so that will be subtracted, because if we find the area, if we integrate this line, we will get the whole area under the line, right? If I integrate this line, straight line, this line with the limits of x as 1, x as 4, I will be getting the whole area under this. And then if I integrate this curve with the same limits 4 and 1, I will be getting only the area under the curve. So I need to find this area. Once I find this, all I need to do is, instead of finding the area, I will be squaring it and then applying the limits and multiplying by pi. So that's going to give me the volume if that area is rotated up through 360 about the x-axis. So the concept of the volume and area is the same. All I have to do is just apply the formula of volume, but the method is the same. So I have volume is equal to, my first equation has to be y is equal to 5 minus x, since I will be taking the limits of x. So a over here will be 1 and b over here will be 4. So I will be integrating with 4 and 1, pi multiplied. My first equation will be y is equal to 5 minus x. I will make y the subject and I should be getting my equation in terms of x since I'm taking the limits of x on the x-axis. So that is 5 minus x dot dx whole thing squared. So you're squaring it, applying the limits, multiplying by pi. So that's going to give me the volume under the line first, minus the volume of the curve under the curve, which is 4 and 1, same limits. The equation is 4x. Instead of writing 4 over x, I'll be writing this as 4x to the power of minus 1, taking this up, dx, and multiplying this by pi 2 and squaring this 2. So first this has to be squared and then integrated. So if I square, so this is squared, 5 minus x whole thing squared. Now if I start integration over here, I will be getting 5 minus x 1 added to the power, which is 2 plus 1, over the new power, which is 3. This I get minus x, because whatever is within the bracket I differentiate this, so that's just minus 1, which is 4 and 1, limits 4 and 1. So that was taken as squared, then integrating it, whatever I apply the limits, whatever I get, need to multiply this by pi, minus, now squaring this, I will get 4x squared, 4x to the power minus, so if I square this I get 4x minus 2, and this is whole thing to the power of squared, so that cannot be taken as 4. 4 is also squared, so this will be taken as 16. So this is 16 x minus 2. Now this has been done, so we have squared this. Now plus 1, integrating it, so the new power comes down and that's just minus 1. Now so squaring is done, this becomes 16, this becomes x to the power minus 2. Now integrating it, so minus 2 becomes plus 1, minus 2 plus 1, so minus 1, that goes down, that's it. 16 is just a constant, nothing happens to the 16. 16 is just going to multiply by whatever x you get, and pi over here, and 4 and 1 over here. So if you do this, you will be getting pi 5 minus x 3 minus 3 4 1 16 pi, this is just a constant, I can take this outside, 16 pi, and I'm left with x to the power of minus 1 over minus 1, applying the limits 4 and 1. Sorry I didn't see, you guys couldn't see this, so I'll just recap on this. So this is just simply integrated, squared, and then integrated, and this is what we get. I've just written this in the simplified form, so I can have this as, now if I apply the limits, I'll have pi outside. If I apply 4 over here, 5 minus 4 will give me 1. 1 to the power of 3, that's just 1, so I'll get minus 1 over 3 when I substitute the value of 4 over here. If I substitute the value of 1 over here, I'll be getting 5 minus 1, which is 4. 4 to the power of 3, which is going to give me 64, and minus, and minus, so that's minus 64 to the power of minus 3. So if I substitute 4 over here, 5 minus 4, that's 1. 1 to the power of 3, that's 1 over minus 3, so that's just minus 1 over 3, minus the upper limit minus the lower limit. Now the lower limit is 1, so 5 minus 1 is 4. 4 to the power of 3 is 64. 64 over minus 3, and that minus sign is for the both the limits have been subtracted. and that minus sign belongs to minus 3. Minus 16 pi over here. This is x to the power minus 1. This is just minus 1. This can be written as minus 1. So if minus 1 is multiplied by the whole thing, and this x to the power minus 1 goes down, so over here 4 will be plugged in, substituted, minus 1 over 1 again, and once I use the calculator and work out the values of all of this, I should be getting my answer as 9 pi. 9 pi would be my final answer, which can also, this is going to be the exact value, leaving it in terms of pi, or I can also write this as 28.3 units squared.